We're going over factoring quadratics. This is a quadratic equation here. It is in what's called standard form. What we're doing is we're taking this form. It'll still be the exact same quadratic, but we're going to move it to factored form. And lo and behold, the process that you use to do that is factoring. I know. So, there are many ways to factor a quadratic expression. I'm going to teach you one way, and I'll show you another that is simpler, and then I'll show you one using algebra tiles in a different example. So, we have this equation here. What I want you guys to get used to looking at is, in standard form, a quadratic has these variables attached to it, okay? In other words, there is a term that can be in front of the x squared, and we usually refer to that coefficient as a. There is a value that could be in front of x to the power of 1, and we can call that coefficient b. And then a constant term, which we call c. So this is our factored form. I want you guys to get used to being able to pick those values out. What is the c value in our equation? 12. The b value? And the a value? 1. Okay, so today we're specifically going to go over a values of 1. I'm going to show you a method right now that works for whether a is 1, 10, a million, it doesn't matter. Then I'm going to show you in another example a fast way to do it when a is 1. But that way only works when a is 1. Okay? So in this one here, what we're going to be doing, take this expression, x squared plus 7x plus 12. Okay? What we do is we find the factors of a. Well, what are the factors of a? In fact, the entire term there. If a is 1, yeah, we get 1 and 1. And since it's x squared, we have 1x and 1x. Okay? Those are the only factors that could actually create this first equation. We then look for the factors of c. What values could create 12? Good. 3 and 4. Excellent. So what we're going to do now is from here is we're going to set these up into little columns, okay? We're going to call these the first terms. Ooh, I don't know what this is. I'm going to try that. Yep, that's what I wanted. Good. Okay. Here are our columns, okay? The red columns are essentially our first factors. There's only one set of first factors that can create this. What we're going to be doing is we're going to be multiplying this first column by one of the columns for our second factor. When they multiply together, they're going to create, where is that? There you go. They're going to create, when we add those two products together, they're going to create our b value. And in this case, we include the x, 7x. Okay? So, when we go through this, we're going to use a method of trial and error to start off. So, 1x by 1, 1x by 12 gives us 1x and 12x. Any combination of adding 1 and 12x give us 7? No. And if we go across, which we should always try, the terms are going to be the same because our first values are the same. Okay? So in this method, we don't technically, or in this example, have to go across right now. Okay? So we know 1 and 12 will not work. We then go ahead and try 6 and 2. 1 by 2, 1 by 6 gives us 2x and 6x. Does that work for 7? No. What's going to work? 3 and 4. Okay. We know, and I'm going to draw a line here because it is very important that we know what we multiplied by. Okay? Well, 1x times 3 will give us our 3x. 1x times 4 will give us 4x. When we add those values together, we're going to get 7x. So now, these terms, this column here and this column here are the terms we're going to put into factored form. So in our factored form, we have two brackets. Okay? The first column, the one we put in red, are the first terms of each bracket. So 1x and 1x. The second column are the second terms in each bracket. Now, they are both positive, okay? And there will be examples where one might be a negative, one might be a positive. We'll get into that later. But in this case, they're both positive. So we have to check what they were multiplied by. Now in this case, I did 1x times positive 3, so they have to go in opposite brackets. Okay, that's where I put my original 1x. So the positive 3 goes over here. And then in our other one, we chose 1x and positive 4. Well, they have to go in opposite brackets. Okay? Now, for this example, because the first terms, again, were the same, that opposite bracket rule didn't really affect us. But when we get into an a value that's not 1, that will become very important. Okay? And this is it. This is our factored form. We don't technically need to include the coefficient of 1 in front of x plus 4, and x plus 3. Okay? So I know a lot of steps, but the reason we went through all of these steps, and this will be done much quicker, is so that you guys get used to this formula, because if you do these process properly, you'll be able to factor any quadratic, including when the value of a is not 1.